Hello and welcome to the Australian Inventors Laser Lab. Today we're going to cram quite a bit into this video. We're going to write some short programs because I want to carry out some tests. I want to find out exactly how low this laser will go. In other words, what percentage of power output of the laser, what's the bare minimum, what percentage does it actually start to fire? Whether it's, well, I suspect it's around about 10%, but it could be as low as 8 or 7. So we're going to find that out today. Then we're going to go up through the range in 5% increments, all the way up to 85% on the program, which is 100 watts on 100% output of the tube. And we're going to see what happens. We're going to use two different types of material. We're going to use 10mm acrylic, brilliant stuff for lasers. This is the only plastic that you can actually cut in these machines. The other type of, all the other types of plastic are not good for these types of machines or for your health. They leave residues which can gum up the mechanism and even play havoc with the electronics. So don't cut any other types of plastic other than acrylic. Also this MDF, 3mm MDF, this and white surface boards, because this material actually leaves a good trace of the actual laser cut that you can measure and examine under the microscope and what have you. So those are the two materials that we're going to be using. Maybe we'll use thicker MDF as well, up to possibly 18mm. So what we're simply going to do is go to the line tool, zoom in to a square and pick a point here and pick a point here. Then go to the select tool and size it. Oh, that's pretty close, but we want it exactly 50mm. Incidentally, when I say, if I sometimes say 50 mil, I actually mean millimeter. It's just a habit that I suppose got into over the years. So okay, that's that one. So now what we're going to do, I'm going to select it again and we're going to array copy. No, I think to begin with, probably somewhere in the region. We're going to do 10 first of all, I think. 10. We're going to have a 10mm gap in between them. And press OK. That's a much easier way to copy a number of lines. So we're going to start off at the top line here, and we'll select that one. That was a black layer. Okay, so we're going to go to the second line down and we're going to select a blue color or blue layer, and third one down, next color along, that one green, that one I think that's buff, I'm not sure, yellow, cyan, brownish, greenish, and mauvish. Okay, So we're going to start off with this black layer here, and no need to actually select those. So you go here and select the black layer one, and so we're going to let me see, 20 millimeter is 20 millimeter a second is fine. We're going to run the full test at that. We'll leave those as they are, and we're going to start off at 5%. I don't think the laser will fire at 5%, but we will find out. 5% and 5%. So this is maximum minimum. That sounds like dinner. Okay, blowing, yes, we'll have blowing. It'll take a second. I'm going to then go to the next layer, and all we're going to do is change the power, and we're going to go 6% and 6% and calculate. So I'm going to do I'll switch the camera off now, and I'll do the rest of these going up in 1% increments, because it's going to get very boring for you guys otherwise. Okay, I've loaded up now the program in the controller for the machine. Now I'm going to use the Z-height automatic setting system. On the back of this there is a magnetic sensor. So this is just a piece of mild steel that's just actually painted. Now I'm going to set the level, and it's just really just press the Z data in the program, and it automatically sets the level. So now I'm going to jog it up to the top here, because what I want to do is I want to start the cut on here, and I know the line is 50 millimeter long, but I want to come off the material. I think we'll start it there, maybe a little bit further over, make sure. The laser beam will be defocused by the time it reaches this, and the laser is going to be absorbed by this black mild steel anyway. So we're going to run this in this MDF white coated material first, then we're going to run it in acrylic. So here we go. Okay, that was the first cut, and you'll notice that the laser did not fire until 10%. So that is the minimum. It doesn't even fire. It won't fire at 9%. So 10% is the absolute first time that the laser will fire. So that's 10 to 15, and this is in the white material. And now what I did to just prove a point, and I'll put it under the microscope in a minute to you'll be able to see better, but I run the test here first, out of focus, and this is, let me see, this is 3 4 5 millimeter, yeah, 5 millimeter out of focus. In other words, too close. So you can see it's a very wide cut, and it did actually make a bit of a cut there at 10 watts, or 10% rather. And yeah, there's 10% again to 15, and we'll have a look at these underneath the microscope. Okay, so the line that we're looking at here is that 10% cut. We'll put the reticule on here now, and you'll see now before we was closer to the 3 than what we was the 2, but this time now it's in focus is exactly 0.2 millimeter. So that's probably the best that we can expect from this 2-inch focal lens on this laser. So you can see it is very, very small. It's a very, very small cut. For example, the out of focus ones, it's a big trench. Big trench. And it's even more than 0.5 of a millimeter. So there we go. So that little experiment has shown us an awful lot actually. Okay, this time we're going to start off at 10 watts and work all our way, or 10%, and work all our way up through in 5% increases to 85%, which is 100 watts on this machine, and we're going to cut it in acrylic. Okay, so I just did that run just now, and yeah, it was as expected, all the way from 10 all the way up to 85%, but it didn't actually penetrate all the way through. So what I did, I ran a couple of tests, and what I found was that 85% and 10 millimeters per second cuts clean through and leaves it nice. So what I'm going to actually do is cut a square out now, which is 50 millimeter by 50 millimeter, or 2-inch square. And in actual fact, it does come out. Oh, look at that beautiful, beautiful flame polished edge. Like I keep on saying to you guys, this is a professional machine. And there it is. It'd be interesting to actually measure that. Let's see what we got here. Set on 0. Oh, hang on. Well, that was 50mm. So the accuracy of this machine is within what? A couple of thousandths of an inch. I mean, that's it. That is the accuracy of this machine, and this is a laser. You'd have to spend an awful lot of money to get a laser with that accuracy. And we have made this machine as a handyman unit, someone that can have one of these in their own garage, start a home business, a hobby, and that's the sort of accuracy you get with all of our machines. So I hope you've liked the video today, and please subscribe, press like, and please visit one of my channels. I've got two now. This is the dedicated to lasers. I do have a few of these videos up on my other channel, which is the Australian Inventors Workshop, where it's devoted to CNC rotor machines and wood lathes, which we also manufacture. So thank you for watching, and it's bye for now.